Hi students, in this video we will see adding a node at first position. Now here this is the linked list. So 1000 is the first node. So this address will be stored in root and 2000 is the second node. So the first node's address part, it contains the address of second node. Second node's address part contains the address of third node. Third node's address part, fourth node's address, and fourth node's next, as it is the last node, fourth node's address part contains null. Now what I want to do here is, here I want to add a new node at first position. Now here this is the linked list. So this is the first node, second node, third node, fourth node. Now I want to create one new node. In order to add a new node at first position, first we need to create one new node. So here we need to create one new node. So this is the new node. Now here this node contains both data part and address part. So this is the node, and this node contains data part and address part. Here you mention here data and address means we have named in our linked list as next, and this node contains some address. Let us assume that the address of this node is 9000. So this is the new node we have created. Now what I want is, now this node contains some data like 99, and initially, so as it is a new node, it contains null. So what we need to do, this node I want to make it as a first node. So tell me what we have to do here in order to make this node as first node. So if this is the first node, the previous first node becomes second node. So what we need to do here is, so if this is the first node, previous first node will become second node. So in the first node's address part, we need to store the address of second node. That is 1000 should be stored here. 9000's next part, we should store 1000. And now which is the first node? 9000. So this 9000 should be stored in root. Now root contains the address of first node, that is 9000. Now when you display the linked list, so now root is pointing to 9000. So 9000, 99 it will display, then 9000 of next 1000. So 10, 1000 of next 2000, 20, 2000 of next 3000, 3000 of next 4000, 4000 of next is null. So in order to add a new node at first position, so first we need to create a new node. Then the previous first node's address, where it is available, previous first node's root, that root should be assigned to new node's next part. In the new node's next part, root value should be assigned. So let me write the code for this. Now here let us take a function. So here let us assume the name of the function is add first, or you can use any name. So add first I have used. So here struct node star new node, because we are creating a new node here and we are accepting one value from the user, that is int n. So in order to create a new node, the memory should be allocated dynamically. So struct nodes new node equal to struct node star, that is memory conversion. How to allocate the memory dynamically? Using malloc function. Malloc, how much memory it should be allocated? Size of struct node. So this statement, this is very important. This statement will create a new node. This new node will be created by that particular statement, and so the variable name, that is the address of this node, will be, this is new node. This is new node what we have created with this statement. Then after that, what we need to do, then the accepted data should be stored in new node. The accepted data should be stored in new node. Here new node of data equal to n. What is n? Accept from the user. Here we need to read n value from the user. Before creating this node, read n value from the user. That is new node of data equal to n. That n will be stored here. This n will be stored here. Then after that, what we need to do? Now this part, let us remove this closing brace. Now what we need to do? Then here you can assign the value new node of next equal to root. This is very important now. What is root? Previous address of root is 1000. In the new node's next part, this 1000 is assigned. This 1000 will be stored in new node's next part. By default, initially it contains garbage value that we will assign to next. Then after that, what is required? This new node's address should be assigned to root. Now which is the new node? Root node. This is 9000 is the root node. So root equal to new node. Root equal to new node. Then close the function. That's it. So this root contains the address of this newly created node. Now if you call again after add function, again if you call display, first it will display 99, then 10, 20, 30, 40 will be displayed onto the screen. Now let us see the execution adding a node at first position. Now let me trace the program. So first create function. So 10, 20, 30, 40. 4 nodes I have created, -1 for exit. Then display function will be called. You can see the output here 10, 20, 30, 40. Now add first function will be called. Then enter the data. So 99 I am entering. Then this 99 you can observe here. So new node of data equal to n. So root's address, that is previous root's address, will be stored in new node's next part. Then after that, root equal to this newly created node's address will be stored in root. Then it returns back. Then after creating, if you see the display function, so it will display 99, 10, 20, 30, 40. This is adding a node at first position. Okay, in the next video we will see how to add a node at last position. Then we will see adding a node at required position, either first or last or middle. User will give some position at that position. Okay, thank you. We'll see in next video.